Okay, so what we're looking at today is we're going to be looking at trigonometrical models as part of the AISL course. So one of our most important goals for today is that you can solve trigonometric equations. This bit here is our main goal. This is our main goal. We're going to have a look at a few different areas of that. So to start off with, we've seen trigonometric functions before, and this is the definition that we see from the last course. How we define trigonometric functions. Let me show you just overview of what this is. What is the, let's say for instance, the sine function. What is the sine function? Now, if you take a right angle triangle such as this one, this triangle is right. Let me see if I can just measure and put the right angle in there. Get this going the right way. There we go. You can see that this is a right angle triangle. So what we've got here is I'm taking the opposite, which is the value here on this one, and I'm dividing it by the hypotenuse, and it's getting 0.5 when the angle is 30. Now, no matter how I change the ratios here or the size of this triangle, as long as the angles stay the same, the ratio between the hypotenuse and the opposite is always going to be 0.5. If I was to change that angle from 30 to a different angle, it will change. But when you have a proportional triangle like this one, we say that the opposite is proportional to the hypotenuse. The opposite is always half the length of the hypotenuse. Always going to be half the length of the hypotenuse when we're dealing with a triangle which has a 30-degree angle. Let me see if I can get to a nice number. So, look, the opposite is always half of the hypotenuse. Now, that's not true for all right-angled triangles, but it's true for a right-angled triangle which has a 30-degree angle in it. So we have a function that will tell you the proportionality between the opposite and the hypotenuse given the size of that angle. So when the angle is 30, the proportionality is a half. When the angle is a different value, the value will change. Now that function is what we call the sine function. So the sine function will give you that value. It will give you the relationship or the proportionality between the opposite and the hypotenuse. And we can use that to solve problems of right angle triangle trigonometry. So to solve this particular problem here, our first step is we've got three sides given in this question. We only need two of them. We're going to go for this side here. So let me just draw that a little bit better. We're going to try and find this side here. Sorry, this angle here, and we'll call this angle theta. So I'm going to use the sine function. So you could use any of them. We use the SOHCAHTOA in order to solve these ones, SOHCAHTOA, like this. And in this particular case, I'm going to use the sine in order to find my angle. I can use the formula that the sine of theta is equal to the opposite divided by the hypotenuse. That's going to give me sine theta is equal to the opposite, which is 3, divided by the hypotenuse, which is 5. That means that theta is going to be, we need to use the inverse sine function. We take inverse sine of 3 over 5. I think it's trig inverse sine 3 divided by 5, and we get 36.9. This is equal to 36.9 degrees. So I'm solving a trigonometric equation here. I'm solving the trigonometric equation sine theta is equal to 0.6. Sine theta is equal to 0.6 has the solution theta is equal to 36.9 degrees. Are there any questions on that bit?
We also do sine 90 over its side. is equal to the sine x over x.
You can do. So a lot of people, they might choose to use a sine rule. It's once you've mastered the sine rule, it's an easy sort of formula to use. But you're wasting a little bit of time because with the sine rule, you're using sine of, let me just do it up here. But you're using sine of 90 over 5 is equal to sine theta over 3. Yeah? Now, there's no problem with doing this. It will give you the right answer. But you are basically doing the exact same thing as me. The sine of 90, try it on your calculator. The sine of 90 is 1. So taking what you've got here, if this disappears, and then taking this and moving it up to the other side, up to there, you're going to end up with sine theta is equal to 3 over 5. So if the triangle is a right-angled triangle, we don't use sine rule, cosine rule. If the triangle is a right-angled triangle, we use SOHCAHTOA. It's a little quicker. But using the sine rule won't be wrong. You're just wasting a little bit of, a few seconds of time. All right, have a go at these two problems now as classwork for 3 minutes. All right, let's have a look at, we'll have a little look at question B. So we're asked to find the unknown angle and the unknown side here in this problem. So the first thing to do is to label up the sides that we have. This one here. So start with identifying where is the referenced angle, the x or the theta. And then look at the two sides. Look at the two sides. This side and this side touch that angle. This side and this side touch the angle. The opposite doesn't. So start with the opposite. Hypotenuse is easy, but identifying opposite and adjacent is always a little bit tricky. But look to see where your known angle is, and the opposite doesn't touch it. So this one is adjacent. Next up, draw up our SOHCAHTOA. If it's a right-angled triangle, we use SOHCAHTOA. This is a right-angled triangle. Next up, we need to decide we are going to go for the hypotenuse. So if we're going for the hypotenuse on this one, we can use SOHCAHTOA, but we can use another strategy when we're working with a right-angled triangle, can't we? If we're trying to find, if we know two sides and we're trying to find the third side, which theorem should we use?
A squared plus b squared c squared.
Yeah. So we would say from Pythagoras' theorem, c squared equals a squared plus b squared, which means that c is the hypotenuse. So z is equal to the square root of 10.2 squared plus 34 squared. What does that give as our answer? Yeah. Let me just do it here on my calculator. Where's my calculator? There it is, right at the end. So we want square root of, oops, no, it's not square root. Square root of 10.2 squared plus 34 squared. And that is going to give me 35.5. 35.5. All right, so there's Z. Next, we need to calculate X. So if we're calculating X, we're looking at our triangle. We've been given the adjacent, and we've been given the the opposite. We've been given the opposite. Although we know the hypotenuse, I calculated that, so I could have made a mistake. So when it comes to selecting how to find the angle, I would recommend that we use tangent, because the hypotenuse length could be wrong. I could have made a mistake. So stick to the values that are given. We're told that the tangent of x is going to be the opposite, 10.2 over 34. So just doing that on our calculator, we therefore need to find x with using tan, inverse tan of 10.2 over 34. Calculate that one. Inverse tan of 10.2 over 34. And we should get 16.7. All right. So that actually is a little bit of a review of stuff you should already know from the previous course. We are going to look at this section today, solving trig equations. So we're going to look at being able to solve a variety of different trig equations here, like this one. Okay, so we are looking now today at AISL. We have this equation, which is given here. Let me just pull up my pen. So we have the equation sine x equals the cosine of x. And then we're given this interval as well. We're asked to find in that interval all of the possible solutions. Now, you can get more than one solution. So get your calculator in your hand now. Get your calculator in your hand and get ready to follow me along. Sam. Okay, so what we see here is this symbol there. Let me just undo that. This symbol there is an element of. So what we've got on this bit is it says that x, it looks like this. It's a set notation. It means is an element of, and then we're given an interval from 0 to 360. So we have to find all of the possible values of x in that interval. So on your calculator, press menu. Calculator in hand now, Saki. Calculator in hand, follow along. Algebra, AISL. Here in AISL, we're going to press trigonometry. We need to type the equation in. So we get sine x is equal to, you find the equals button over here on the left-hand side, to the left of the 7. And then cosine of x, comma x. Now don't press enter at this point. At this point, what we want to do is we want to put in the interval. So we need another comma. So we want another comma. We can find the comma down here. Put in comma 0, comma 360. So type in the interval and then press enter. Now it will give you one answer. So AISL, you need to learn what AISL does. AISL will give you the answer closest to 0. Or if you've given it an interval like this one, it will give you an answer closest to 0 in that interval. So if there's another answer, it will be bigger than 45. So we go back to AISL by press the up arrow here twice and pull up what you entered and press enter, and it will copy it down. And then just scroll inside here and remove that 0 and make it 46 instead. So now you're telling AISL to look in the interval from 46 to 360, and it will find you another solution. So our second solution is x is equal to 225 degrees. We want to see if there's any more solutions. So scroll up, Copy NSolve down. What should we change the 46 to this time? Do we want 225? We want 226. It wants to be just a little bit bigger, so it misses the 225. When you get no solution found, that means there's no more answers to be found, and we found all of the solutions. Our goal is to find all of the solutions. All right, let's do another one. Let's do the second one, and I'll run through it on the calculator for you here to begin with. Do this as another example. So we are going to try and solve this equation. Cosine of 2x is equal to 0.03, cosine of 2x is equal to minus 0.3. So menu, algebra, NSolve. Type in the equation that we see that we're going to solve. We use the trigonometry, so let's pull up the cosine the cosine. We want 2x equals. Now for the negative symbol, use this negative symbol here under the 3. Don't use the subtraction symbol. And then we want 0.3, comma x, and then type in our interval, 0 to 360. And then press enter. We can see that we're going to get our first solution, and we can list the solutions if you want like this. So we can have 53.7, let me just put it as 53.7. And then comma. You can separate them with a comma if you want. So we scroll up. Which number should I change? So I remove the 0 and I make it what, Barn? 54. And I get my answer 126 I can go for. I'm going for 3 significant figures. Let me fix my calculator and put it into 3 significant figures. So document 7.2. Change this fixed 2 to float 3. And then I don't have to think so much. Yeah, 126. All right. So which number do I change this time? Somebody other than Barn. Which number do I change? The 54? What will I change it to? 127. Excellent, Farrell. Should always write every answer to 3 significant figures, unless specified to do something else. Either exact answer or 3 significant figures. For NSolve, you have to move it to, you have to change the interval so that the answer you just got isn't in the interval. So you move it further along the interval. If you imagine the interval is a line of numbers from 0 to 360, you move it further along the line. Which number should I change? Somebody else, which number should I change? Grace. 127, what shall I change it to? If I use 234, it worked this time because that one's been rounded, but ideally you want to go a little bit further on. So we get 306, and then lastly, let's take that one and change this to 307. No solution found. That means we have found the full set. So this equation has 4 solutions. This equation has 4 solutions. Okay, what I'd like you to do now is try NSolve out for yourself and have a go at these 2 equations for yourself. I'll give you 4 minutes for this one. I'll come around and help. All right, let's have a look at our answers here. So I'm just going to clear my screen. I'm going to press Menu, Actions, Clear History. Clear my screen up a little bit. So we want Menu, Algebra, NSolve, and then we want 2. Generally, if it doesn't work in NSolve and it gives you an error message, I would generally recommend writing the multiplication symbol. So if you have x times bracket something, you should write the times in. When we write it by hand, we write x bracket. But sometimes if you have x times a function, my general recommendation when using NSolve is to write the multiplications in as well. And that will help catch some of the errors that you're going to get. So we've got 2 sine x is equal to cosine of 2x. And then we say solve for x. And then we say solve from 0 to 360 degrees. Our first answer is 21. So x, let me pull up a pen. X equals 21.5. Let's find our next answer. I'll shuffle this 0 up to 22. Press enter. 159 degrees. I will change that 22 to a 160. No more solutions found. So these two are all of the solutions to that equation in the given interval. Okay, let's try the next one. So we need the menu algebra NSolve. And then we want the sine of x. So sine of x is equal to 0.5. And we need to find all the solutions from 0 to 180. Oops, I missed something. What did I miss? I missed solve for the variable x. So here I need a comma x. So our first solution is x equals 30. And do we have any more solutions? Let's change that to a 31. And we get 150. All right, let's have a look now at this pair discussion. So I'll give you a couple of minutes for this. When it comes to solving a trigonometric equation like this, we've got 3 strategies. So our first strategy, I don't have much space here, but let me just write it down here, is if we have the cosine of x is equal to 0.6272, we can find the inverse cosine, cosine to the -1, and this will give us one answer. So let's try this one on the calculator. We can take the trigonometry inverse cosine and then type in 0.672. And we get x is equal to 47.8. So that's one strategy. What's the advantage in this strategy? It was quick. What's the disadvantage of this strategy?
I'm not sure.
It only gives you one.
It only gives you one solution. It only gives you one solution. So we can NSolve it. We can NSolve. And then with that solution, it's going to give us the same answer. It's going to give us the same answer, 47.83. We just show you how to do that on the calculator. So menu, algebra, NSolve, and then we can type the equation in. So we've got cosine of x is equal to 0.672, solve for x. And then we can go in and we can look, is there any more solutions? Maybe from 48 to 90. No more solutions. So we get the exact same solution. What is the advantage of NSolve here for us? What is the advantage of NSolve?
You can
We can put the range we want. We could get more than one solution if there are more than one solution. Our third technique, did anyone come up with a third strategy? That we've actually seen another strategy that I've not used today, that we've seen for solving equations. Graphing. We can graph it. So let me show you how that would look. So we can press Control, Add Page, add a graph page. You can solve any equation by graphing it. You set two functions. You graph the left-hand side and you graph the right-hand side. So the left-hand side of this one is that the cosine is basically the cosine of x. That's the left-hand side. We can add in the right-hand side. We press Tab, and the right-hand side is 0.672. Type that one in. Then we need to adjust the window settings to go from 0 to 90. So Menu, Window Settings, and I'm going to go from 0 to 90. I can make this a little bit smaller. And then we get two graphs like that. Where is the solution in this graph? Where is the solution to the equation? With the intersection point. So we can press Menu, Analyze Graph, Intersect. And we can see that there's one intersect, and here is the answer, 47.8. So we still end up with our third strategy, which is to graph it, and we get x is equal to 47.8. What is the advantage of this solution? What is the advantage of this solution strategy? This is a very popular solution strategy. You get a visual picture instantly of how many solutions there are going to be. You can look at the graph and say, all right, there's only one solution here. With NSOLVE, we're sort of guessing in the dark until it tells us no more solutions. With the graph, you get to visually see it. The disadvantage with the graph is it can take a little bit longer. It can take a little bit longer. If you get quite quick with NSOLVE, that's a much quicker technique. Now, which technique is best? Which technique is best? Well, the first technique is the technique that we use for right-angled triangles. This technique here is useful for right-angled triangles because in a right-angled triangle, you're only ever going to get one solution. So we use this strategy. NSOLVE and the graphing ones are used when we're working with trigonometric functions and there's multiple solutions. Neither of them is preferred. NSOLVE is a little bit quicker. The graphical approach, you visually see the number of solutions. So you have to get a little bit careful. So if the strategy changes up to 0 to 360, we would double click here on this 90 and change our interval now from 0 to 360. How many solutions would we expect to find?
2.
2. Why, Zaki?
Because it crosses the two intersections.
Yeah, you see how great this strategy is for very quickly visualizing how many solutions we're going to get. So the second solution that NSOLVE would give us would be 312. Let's just check that one. Let's change the interval. We found the first solution. Let's change the interval to 360 and we get 312. And then there's no more solutions after that. Bon.
So when you're graphing it, do you want us to put 0.1 instead of 0 as like the graph of where it's supposed to go?
I'm not following the question.
When you're graphing the graph,
Yeah?
in the left you put 0.1, not 0.
I don't think I don't remember what I did, so no. So here, let's have a little look. I put from 0 to 360. It's just, I think that's 0.1 is the y-axis scale that's been automatically given to us. That's because I made the y-axis go from -1 to 1. That's just showing what the scale is on the y-axis. But I often do, if I'm going from 0 to 360 on my window settings, I often do start it off a little bit lower than what it is. So if I started here at -5, let me just -5, I like to see the axis. I like to see the axis a little bit. So I do have a preference for doing it that way. All right. let's have a look. Last up for us is to have a go at some questions now. We're going to have to leave the exam style question for another day. We're going to have a look at example 1, and I can do this one example. Take a couple of minutes to read the question and have a think through it, and then I will show you a solution. All right, so we have a Ferris wheel which is planned. And what we need to do is we need to sketch this a little bit. So let's draw up some axes. Oh, that's not going to let me do that. If I draw in my Ferris wheel, it's going to look like this. The height of the Ferris wheel, given that the Ferris wheel is planned 70 meters. So the radius of the Ferris wheel, that means that this distance here is 70. So, Farah, Malik, shh. Okay, we have an angle rotated in this direction from anti-clockwise from the x-axis, like this. And it will give you the height. So when the angle is, if we have the ground down here, like this, so when the angle rotates all the way around to 270 degrees, it's going to be 0. So we need to find the size of, we know that this here is going to be 70. We need to find the height here. So this makes a little right angle triangle like this. We've got a little right angle triangle like that inside there on our Ferris wheel. This is the radius, which is 70. We want the height to be 40 meters above the x-axis. So we want this to be 40. And we need to find the angle that will give that. Now obviously we can see that there's two possible solutions, because you could be 40 meters above the x-axis here, and this angle will be somewhere between 0 and 180. So we take SOHCAHTOA, because we have a right angle triangle to begin with. We take SOHCAHTOA, and that gives us that the sine of the angle is equal to the opposite over the hypotenuse. If we n solve this now, let's have a go at n solving it. So let me pop that up. So on our calculator, we just need to do a quick calculation. We do menu, algebra, n solve, and we want sine of x is equal to, control divide, 40 over 70. Solve for x, solve for 0 to 180 degrees. Oops. Sorry. Solve for x, and we get 34 as our first answer, 34.8. And then let's just solve again for the second one. We want to put in 35, and we get, or it's going to be 145. Sorry, let me just pop that one up. Okay, we're going to have to finish there for today. Have a go at the homework exercise 11A.